Students, today we see the linear equations into variables, the equations which are reducible to the simultaneous equations. आज आपण अशी इक्वेशन्स पाहणार आहोत की जे सायमल्टेनियस इक्वेशनमध्ये आपण कन्वर्ट करू शकतो. वी कॅन कन्वर्ट दॅट इक्वेशन्स टू द simultaneous equations. They are not linear equations. For example, we take two equations. Let 4 upon x plus 3 upon y is equal to 1. The first equation is given, and second equation 8 upon x minus 9 upon y is equal to 7. That is the second equation is given. This is not a linear equations into variables because the degree of the variable x is -1 and y is also -1. That means these are not a linear equations. But we can convert these equations into the linear equations by making a suitable substitutions. That means if you would put 1 upon x is equal to some variable, let 1 upon x is equal to m and 1 upon y is equal to n, then these equations become a simultaneous equations, and then we can solve these equations by any method of the solving simultaneous equations. Let we have to solve this example. Put here, these are not linear equations into variables. First we have to put 1 upon x is equal to any variable. Let we get 1 upon x is equal to m and 1 upon y is equal to n. Then first equation become, what is the first equation? 4 upon x. That means 4 into 1 upon x plus 3 into 1 upon y is equal to 1. Hence these equations become, we put 1 upon x is equal to m, therefore first equation become 4m plus 3n is equal to 1. That is equation number 3, which is a simultaneous equations. Similarly, in second equation, this is 8 into 1 upon x minus 9 into 1 upon y is equal to 7. Substitute 1 upon x is equal to m, we get 8m minus 9n is equal to 7, which is equation number 4. Now we can solve these equations by any methods. We get the equating coefficient method. For this, we make the coefficient of any variable is same. Let we multiply 4 we multiply 3 by 3, we get multiply equation 3 by 3. Hence we get equation number 3 is such that 3 into 4 is 12m plus 3 into 3 9n is equal to 3. That is equation number 5. And we write the another equations below it. 8m minus 9n is equal to 7. That is equation number 4. Now we have to solve these equations by adding these two equations. We cancel plus 9n and minus 9n. That means 12m plus 8n is 20m. Is equal to 10. Hence m is equal to 10 upon 20. Therefore m is equal to 1 upon 2. Now we have to substitute this in equation 3, 4. We get 4m plus 3n is equal to 1. 4 into 1 upon 2 plus 3n is equal to 1. Hence it get 2 plus 3n is equal to 1. Take to the another side. 3n is equal to 1 minus 2. 3n is equal to minus 1. Hence n is equal to minus 1 upon 3. We get the value of n is equal to minus 1 upon 3 and the value of n is equal to 1 upon 2. Now, but the variables are x and y. We get the values of m and n. Now we will substitute these values in the equation and we get the value of x and y. Now resubstitute value of m. We get 1 upon x is equal to m. Therefore 1 upon x is equal to n. The value of m is 1 upon 2. Hence x is equal to 2. Similarly, we substitute the value of n. One upon y is equal to n. Hence 1 upon y is equal to minus 1 upon 3. Therefore, we get y is equal to minus 3. Hence, our solution is, the final answer, our solution is x is equal to 2 and y is equal to minus 3. That is our final solution. This is the method which is called the reducible equations reducible to the simultaneous equations. That means the equations are not a simultaneous equation. We can convert that equations into the simultaneous equations and then we have to solve these equations by any method. Here I solve this equation by equating coefficient method. You can solve this equation by substitution method or by Cramer's rule also. Okay. Now we saw another one example. Let 7 upon 2x plus 1 plus 13 upon y plus 2 is equal to 27. That is equation number 1. 13 upon 2x plus 1 plus 7 upon y plus 2 is equal to 33, equation number 2. Now here 1 upon 2x plus 1 we get one variable and 1 upon y plus 2 that is get one variable. Let to substitute this, suppose 1 upon 2x plus 1 is equal to a and 1 upon y plus 2 is equal to b. Now these equations become, the first equations become 7a plus 13b is equal to 27, and the second equation become 13a plus 7b is equal to 33. That is equation number, this is equation number 3, and this is equation number 4. Now we can solve these equations by any method. Here the coefficients are interchanged, 7 and 13, here 13 and 7. That means we can solve these equations by adding and subtracting methods. First add 3 and 4, we get the simple equations. Add equation 3 and 4, we get 7a plus 13b is equal to 27, and 13a plus 7b is equal to 33, which get 20a plus 20b is equal to 60. We get 20 common, a plus b is equal to 60, hence take the 20 to the another side, we get a plus b is equal to 60 upon 20, hence a plus b is equal to 3. That is our fifth equations. We add here, similarly we subtract these two equations 3 and 4, subtract 3 from 4. That means we write the fourth equation first. 3a plus 7b is equal to 33, and 7a plus 13b is equal to 27. Now we have to subtract this, that means there is negative sign, hence we have to change the sign of second equation. 13 minus 7, we get 6a minus 6b is equal to 6. Take 6 common, we get a minus b is equal to 6, hence a minus b is equal to 6 upon 6. Therefore a minus b is equal to 1, which is equation number 6. Now we get the simple equations. We add these equations and get the values of a and b. Let add equation 5 and 6. That means a plus b is equal to 3, a minus b is equal to 1, plus b minus b get cancelled, hence 2a is equal to 4, hence a is equal to 4 upon 2. Therefore a is equal to 2. Substitute this value in equation number 5 or 6. Substitute value a is equal to 2 in equation 5. We get a plus b is equal to 3, therefore 2 plus b is equal to 3, hence b is equal to 1. But we have to find the values of x and y. We get the value of a and b here. A is equal to 2 and b is equal to 1. Now resubstitute these values in the equations, we can get the second equations. I rub this. Let resubstitute values of a and b. A is equal to 2 and b is equal to 1. That is 1 upon 2x plus 1 is equal to a. That is 1 upon 2x plus 1 is equal to 2. We get a reciprocal 2 upon 1. That means the 2x plus 1 is equal to 2. Take the 1 on another side, hence 2x is equal to 2 minus 1. Therefore 2x is equal to minus 1, hence x is equal to taking cross multiplication, we get 1 is equal to 2 into 2x plus 1. That means 1 is equal to 4x plus 2. Take the 2 another side, we get 4x is equal to 1 minus 2. That means 4x is equal to minus 1, hence x is equal to minus 1 upon 4. Similarly, putting the value of b at here, 1 upon y plus 2 is equal to 1 upon 1. By getting reciprocal, y upon 2 is equal to 1. Take to the another side, y is equal to 1 minus 2, hence y is equal to minus 1. Now we get the values of x and y. That is our solution. Hence the solution is x is equal to minus 1 upon 4 and y is equal to minus 1. That is our final answer. Now we solve the next exercise of our book.